Well. It's a wonderful day. As you can see, it's looking very nice. This morning, we are going to look at an equation, once again, in physics, called the Snell's law. Okay, it's not necessary for you to understand the principle behind Snell's law. The Snell's law says the refractive index of a glass from air to glass or glass to air is given as a sine into bracket A plus D subscript m all over sine over A over 2. And in this wise, we have been asked to make the m or the d minimum the subject. So that is the equation as you can see over here. But as I said earlier, we don't need to understand the equation. Let me rewrite the equation once again for us to have a closer look at it. Okay, so our solution, so we know the refractive index is given as sine of A plus D subscript m all into bracket divided by sine of A over 2. Okay, this is a Snell's law. Okay, Snell's law equation. But as I said, our interest is not on the physics aspect of it, but our interest is to be able to make the dm the subject. Alright, so how do we do this? How do we go about it? Well, as I said earlier, in every equation, what you do to the left hand side is the same you do on the right hand side. Okay, so as you look at it, we are going to break it down. We must be able to get rid of this sine A over 2 here. So sine A over 2 is our issue. So sine A over 2 is the issue. If that is the case, what we have to do is to get rid of it, meaning we have to multiply through by sine A over 2. So we say multiply the left hand side by sine A over 2 and the right hand side by sine A over 2, just to get rid of it. Alright, so we knowing that our equation is given as sine A plus D subscript m all over sine A over 2. So as we said, we are going to multiply here and here by sine A over 2. Well, let us demarcate or illustrate it with a different color so we understand. So we are multiplying here by sine A over 2. Then we multiply here by sine A over 2. Have you seen it? So all what we've done is multiply both sides by sine A over 2. When we crossed them together, they didn't do anything, but we can cancel it easily. So we can see that by so doing, the right hand side will cancel each other. This will cancel this. So we'll be left with sine A over 2 multiplying the whole equation, which is sine, so that's just n times n is equal to sine A plus D minimum or subscript A sine A over 2. You see, friends, does it make sense? So then we say mathematically this is now gone because this multiply this, so this one is gone, so that we're not going to have sine A over 2 sine A over 2 again. So our equation now is going to be n sine A over 2 is equal to sine A plus D subscript M. Have you seen it? So you see that it's become so easy for us to be able to work it out. Okay, now, now, you see that on the right hand side, we still have sine into bracket A plus D. Well, I'm going to do something, some simple little illustration for you to understand where we are going to go when we go to this point, how to get rid of the sign over there for us to be able to make the D subscript and the subject. You can see that we know that if we have a tan theta, if it's equals to P, yeah, and mathematically, if I want to make theta the subject, I will say that theta, yeah, is equals to tan inverse of P. That is how I can make theta the subject. In the same way, if I have sine theta is equals to P or Q, to make theta the subject, then I can say that theta is equals to sine inverse of Q. Okay. In the same way, if I have cos theta is equals to maybe T. Okay. How do I find my theta? My theta will be equals to cos inverse of T. So that's why I can make theta the subject. So we are going to apply this knowledge over here where we see the sine into bracket A plus D. Okay. Okay, so now let's go back and rewrite our equation for us to know where we are. So we say that n, okay, sine into bracket A over 2 is equal to sine A into bracket plus D subscript. So you see, now we are going to say that, okay, we have to make this one the subject. Okay, we see this will be equal to sine inverse. Okay, now we for you to be able to understand it properly, let me illustrate it with something that will make it easier for us. Okay, so let, in the first place, okay, let A plus D subscript M to be equals to maybe capital T, so that we rewrite our equation, okay, as sine A over 2 is equals to sine T. Okay, so to make the T the subject over here, I'm going to say that this implies that sine T, let me change, so sine T, which is equal to n sine A over 2, okay, to make the T the subject over here, I'll say T is equal to sine inverse of this sine A over 2 into bracket. Have you seen it? So all what we do we did is to put A plus D subscript M to be equal to T, so that it doesn't, become so much on our eyes. Okay, so now look at it. So this and that. Okay, so all what we are going to do is to substitute this back into the equation. Okay, so now we can say that in place of T, we say A T, since we know T is there, so it's A plus D subscript M is equals to that. Okay, now let's see. Have you seen it? So we have S sine inverse of the whole equation, sine A over 2 that. You see? So now let's look at it. How do we make dm the subject? Remember that we are going to okay, subtract. We are going to subtract capital A from both sides of the equation. From both sides of the equation. So now we know that I will put it down as the way it is. So we have A plus D minimum, which is equals to sine inverse of the whole expression in the bracket all over 2. Okay, so we are going to subtract A from both sides. And we know that in maths, what you do to the left hand side, you do to the right hand side. Let me push this one backward a bit for us to be able to understand what I'm trying to say. Okay, so now we have A plus D M, which is equal to the equation we have over here. So we are going to subtract minus A from both sides. So we subtract A from here and A from here. Have you seen it? So what do you see? This A, we take away this A. Have you seen it? So we'll be left with dm alone. Yeah, dm alone being equals to sine, okay, inverse of the whole, okay, sine A over 2, okay, minus A. So you see that we are able to make our dm the subject of the equation. So this is what is expected of us to be able to solve, to make the dm the subject. Now, I know some of us, because of the nature of the equation, will maybe a bit distracted. Well, I want you to just be assured of yourself that if you stick to the equation given, you will not go wrong at all. So with that, let us use this 5 seconds or 2 minutes to recap the whole process, how we got to this equation. So our final answer now we know is dm is equals to sine inverse all of that and the sine A over 2 into bracket. Okay, so all this one minus A. This is the equation that we're supposed to have. Okay, so sine inverse of that is given as that. Okay, but let me take this one away from it before it confuses you. So this is the whole equation that we're supposed to get. Okay, so sine inverse of this, sine inverse of that minus A. This is the equation that we're supposed to get. Now let's go up there and see how we can break it down. Okay, now let's see. The first and foremost, as I told you, don't look at how the equation looks complicated. That is not our cup of tea. Okay, our cup of tea is to be able to understand the principle behind how to do change of subject. So as we saw earlier, okay, the equation is given as n, or in the first system, the same refractive index is symbolized as that is equal to sine into bracket A plus D subscript M all over sine A over 2. So you see that the sine means over there A means A plus D subscript M is an angle. The same way sine A over 2 is also an angle. Okay, but remember, I told you in every equation we do, do to the left hand side, we'll do the same on the right. Please, don't forget that. So that's why right from the scratch, before we even commence, I said earlier that what to do to the left hand side is we do the same on the right. So our left hand side, okay, that is what I've denoted by LHS. Okay, our LHS, okay. So our LHS, this is very, very important for us to remember that what we do to the left hand side, we do to the right hand side, so that we will never get wrong. We'll never go wrong at all. Okay, so we say there, multiply the left hand side, the LHS, by the sine A over 2, which is our issue, this, because it was the denominator of the equation, and we want to get rid of it, so the equation will be straight for us to be able to do it. Okay, so we multiply the left hand side, LHS, by sine A over 2, and we did the same on the right. See, that is why I mark it here. So we multiply both sides by sine A over 2. Okay, and this. Okay, so what we do to the left, we have done on the right. You know that when we bring this equation down here, like that, you see, when we divide this, it becomes 1. So we haven't done anything at all. Okay, so we cancel that. That's why I just repeated it over here. Okay, we repeated it for us to be able to see. Okay, so you see that sine A, this, we'll cancel this one. Have you seen it? So we'll be left with the product, this sine A over to multiplying this n, look alike. So then we summarize it here that n sine A over 2 is equals to sine into bracket the sum, which we haven't changed anything at all. That's what we have on top here. Okay, so after that, okay, this is the equation we got to. Remember, this equation we got to at a certain point. That's what we had. When we got rid of the sine A over 2, it became a straight linear for us to be able to manipulate. Then, for me to work it out on the right hand side, I explained this principle that if you have tan theta to be equals to P, okay, which we can say to find the angle theta over here, we say theta is equal to tan inverse of P. Likewise, if I have sine theta is equal to Q, this will be to find the theta will be equal to sine inverse of Q. In the same way, cos theta is equal to T, to find the theta is cos inverse of T. Obviously, so we applied the same principle here. So instead of the whole A plus dm, I denoted this by saying let that one to be equal to T. So then our equation became n sine theta A over 2 is equal to sine T. Okay, so I will write it. I shift this one on the right and this on the left, which doesn't change anything at all. Okay, so now I said to find the theta, to find the T over here, we say it's equal to sine inverse of the whole product on our right. So okay, then after that, I brought the A plus D subscript M, which is equal to T, back into the equation. Okay, to denote the T we put here. Okay, now we are, getting closer to our destination. So A plus D subscript M is equal to sine inverse of that. How do you do? What do we do? And what do we do to get rid of the A on the left hand side of the equation? So that is what I said. We are going to subtract. Okay, we are going to subtract A from both sides of the equation. Okay, now we have subtracted A from the both sides of the equation. So that's what we did. Okay, so we subtracted A from the left here, we subtracted A from the right. And you know this A here will take away the A here. So then we'll be left with what? Our D subscript M to be equal to sine inverse of the whole expression as we subtracted the A. So hence, change of subject we expected to do. So this is a change of the subject. Okay, change of the subject. So you see that right now we have able to do it such a way that the desubscript is started on its own. Friends, this is where I think we'll say goodbye or part ways. But in the meantime, please broadcast. Tell your friends about our wonderful tutorials going on here. And let them subscribe. And at the same time, if they click on the bell, wonderfully, every tutorial we're about to embark on, you'll be the first person to see it so that you'll be alert. You have a lovely day. Till we meet again. Bye.